I will post the recordings later, so you can watch the videos of your recordings, of all the recordings. And this is our course on iCollege, okay? So everything will be posted on iCollege. Anything that I say, that I do, okay, in this class, that will be posted on iCollege. This is our course. And if you click on the content, the first thing that you should know, I don't know if you have taken the course since summer. Since summer, Georgia State has put this new restriction that every science student has to take all the exams and quizzes, any course assessments using Respondus Lockdown browser. So if you are not used to that, if you are not familiar with that, I would recommend by today, you just download this Lockdown browser from Georgia State. This is free. So you go to the GSU site and you just download this browser and practice, because it will come gradually. Okay? So all the quizzes, all the exams in this course, you have to take using this browser. Okay? So what is the specialty of this browser? This will lock you from opening any other application while you are taking the test. So like basically stopping all the distractions while the student is taking the test. Okay, and then this is the first thing that you should practice. And then another thing, after you read the syllabus, you have to take the role verification quiz. So since I'm not giving you syllabus, or I'm not seeing you all every day, okay, every week. So that's why we have this syllabus role verification quiz. So this is the only way I can check your attendance. Okay? So please complete this quiz. Without completing this quiz, you are not going to get any grade. If you only complete this quiz, then you are going to get any grade in this course. Okay, all your grades will be on hold until you complete this syllabus and role verification quiz. Although we have 2 weeks to complete that, but I strongly recommend that this part you take care of it as soon as possible. And this is not hard. I'm not really quizzing you. I'm just asking if you know everything. Have you read the syllabus? Yeah. Let me see how many people have taken so far. I have 8 people who have already taken, and 9 people have already tried responders. That's a very good. Almost half. I have 20 students and almost half of the people have tried. Very good. Okay, so the other thing that I would like to tell you is the CHEM 101 app. Okay. So CHEM 101, that is for homework. So this is like an app because we are mostly doing all the things on web this semester. So that's why I'm trying this. Okay, so this is my first time. First of all, I should tell you, this is my first time using this. So I am just like you. Okay, I have to also see the way how it works. Okay, I have set up my account. Probably you have seen. Let me go to the. Okay, so if you are taking this, CHEM also Dutta, this should be my course, and this is the course code. This is a low-cost homework program based on our textbook OpenStax. So I use OpenStax textbook, not the Zoomdall, because I'm more comfortable with OpenStax than Zoomdall. And this homework program is based on the OpenStax. So if I click on the homework, you should see that we have now liquids and solids chapter 10 is available for you to start. And all the assignments are due just before the test night. Okay, so if you look at the exam schedule, all your homework should be due before the test. So I'm not putting any pressure on you. You guys try, you guys practice, and you guys finish before the test. So right now I can tell you that chapter 10 and 11 should be due before test, first test. Then chapter 12, kinetics, 13, part of 14, 14.1 to 14.3. Up to this part, they are all due before test 2. And the remaining part, chapter 14, 15, remaining part of 14, 15, 16, and 17, they are due before test 3. So I have 3 tests, and they are all on iCollege. They are all online. And these are the homework that you have to do. So about 40 questions per chapter on average. Okay, some may have less than 40, some may have more than 40, and you are getting like 3 to 4 weeks. So I think that is a doable job. And this is your only practice. I'm not asking to do anything else other than this. And before the test, I'm gonna post a review quiz, and I will give you 2 attempts for that. For every review quiz before test, there should be 2 attempts. So you guys can practice the questions. And then you take the test on iCollege. So what are the test dates, right? Let me show you the test dates. This is our PowerPoint. I want to go back to my iCollege. Oh, it's recording, right? Oh, so many things we have to know. Okay. So your job is to take the role verification quiz and try the responders lockdown browser and register on CHEM 101. I can also see how many people have already registered. Oh, wow. I have so many people already registered. So from today, you can start. Nice. Thank you so much for taking care of your education. See, we should not fall behind during this time. Very good. Okay. So this is our syllabus. It is still Word format because every day I hear something new and I have to put. So this is still not in PDF, the final. Hopefully this is my final version. Okay, so these are my meeting times. As you know that I cannot meet you in my office, just like I have done before, but we can meet in this WebEx room. So if you come to this WebEx room during this time, you should be able to find me. Or if you want some other time, I'm flexible. Okay? Because you know I'm teaching partly online and partly on campus. So sometime I'm at home, so I can take you at any other time. So I'm very flexible. That's what I'm saying. So make sure you make appointment if you want some other time. And if you come during this time, I can take you. This is our calendar. You all know that October 13th is the midpoint. I just need to remind you. And the best part is this, the most confusing part, which is the group attendance. Now this I wrote like 2 weeks ago. So when I had a different group of population students. So today when I'm seeing the schedule attendance class roster, I'm seeing another group of students. So some students have changed, okay? And I still want to hold this attendance. Only thing is that I should not have like more than 2 students per bench. Okay? That's the normal thing. So if anybody wants to change this schedule, just email me, okay? Then I'll take care of that. If I have some people less in some group, some more people in some other group, and if your other schedule, if your other classes are on the same days, you can always request me, okay? I will try to make things work for you. So this is what you have to record, the dates that you want to come on this campus. Okay? And the exam, this is our schedule. That is normally I will follow. And then the exams. Exams are this, okay? So you see that chapter 10, 11, and part of 12.1 and 12.2. And the dates will be Monday and Sunday. Sorry, yeah, Sunday, Monday on iCollege, yes. Sunday from 12:01 through Monday 11:59 on iCollege. So 9:20 to 9:21. And then second test will be the remaining part of chapter 12, 13, and 14, 1.1 through 1.3. And the rest will be in the Unit 3 material, which is scheduled, the test is scheduled from 6th December through 7th. And your second test is 25th October to 26th. So basically you see that the last week of every month, I'm giving one test, okay? And since the last week of November is like Thanksgiving and everything, so I have pushed the exam to the next week, December. Any question you have so far that I'm showing? You guys have any question?
We can't see the screen on our side.
You can see the screen?
No.
It says people are viewing your screen. Okay, let me stop and do again.
Oh, yes, now it's working.
For some reason it was paused, right? But it is getting recorded, so you can hear. So this is I just discussed the schedule and I just showed you the CHEM 101. And the group attendance. Those are the three important parts. Do you guys have any comment, questions?
Those are group times that you actually have to come, but you can come whenever.
No, these are the required attendance for based on your group. And then other classes you have to join online unless you make any request officially, and I have to see how many people are coming in other groups, and based on that I can move you from one group to another group.
That's what I'm saying.
Yes, yes, correct. Yes. Yeah, it is mostly, you see, you're coming only on 7 days in the semester. So the people who are coming on 25th August today, you guys are coming next on 8th September, and then 22nd September, and then 6th October, twice a month, basically. Yeah. Because I'm meeting 1/4 of my population. I have 20 students, and I expect maximum 5 students in each group. And if somebody wants to flip or somebody wants to move, like I already have requests for that. And then you may see maximum 6 students. And that should be fine, right? 3 people this side, 3 people on the other side, that should be. Okay, so 9 o'clock, we should start our material. Okay, I'm gonna open the textbook. If you go to the openstacks.org, you click on science and then chemistry, and this is your textbook. You can download this. You can download on your phone. This is the app, okay? I think I have downloaded, yes, from my last semester. So right now you should be seeing our textbook, and we will start from, let me do this later. We'll start from chapter 10, liquids and solid. I'm missing my tablet because normally I write and people see on the screen. Next time.
Professor,
Yes.
I have a question before you
Yeah.
start the lecture. For the ACS test, it's gonna be online?
Yeah, so I don't, very good question. I, we are informed that the final exam will be ACS, but nothing more than that. So I don't always, I don't have enough information to talk about that.
Okay.
Right now, we even don't know what is our final date. We just know the window between 8th December to 15th December. We don't know what exactly the dates you guys are looking. And then again, the final exam, there is the question. I know that it will be a SCS exam just like in the regular, but I don't know more than that. So I should not comment anything. If I have enough information, I will let you.
Thank you.
There is a study guide. There is a study guide that you can purchase from the SCS examination institute. So it says SCS examination. If you go to this site, CHEM exams, it has moved, and you should be able to purchase from here the study guide, because for final we are not supposed to provide any study guide. See the assessment materials or student study materials. Yep. If you come over here, I think second term you fall under this. Okay. To order a practice exams. So this is about general chemistry. So you can purchase this for $25, general chemistry study guide. You can purchase this for online, timed online general chemistry, full year practice. And this is bundle, okay? Whatever works for you, you can purchase based on that. So these are the study guide available for final, and final exam as usual is ACS. That's all I know. I do not know anything more than that. So when I know for sure that what is coming to you, how it will be administered online, how the information will be distributed to the students, I will definitely mention that. Okay. Anything else? Please go to the ACS Exam Institute and just browse. You just look around and you should be able to see this study guide. So I can start the lecture now. Everybody is seeing the screen. I will use the PowerPoints because that will help you. And basically I will continue my lecture, but you guys will be seeing different materials every day, and different groups will be coming. So I have first chapter, we have 6 sections, and the last one I made optional because everything going on, I don't want to discuss these things more in detail. Okay? So we will just learn 1 through 5. Okay? And I have 3 days for that. So let me start. So this chapter is about solids and liquids. Now in Chem 1, you have learned about gases, right? You have learned ideal gas law and other things about gases like kinetic molecular theory. So that is the last chapter of Chem 1. So Chem 2 just starts from there. Okay, Gen Chem 2 starts from the end of Gen Chem 1. So now after learning gases, we are learning solids and liquids. So this chapter, you can also say that this is about condensed phase, condensed matter, liquids and solids. So what is the first thing that we learn? We learn intermolecular forces. So that's a very important thing. So if you know that we do, you guys can hear me me? The WebEx people, can you still hear me?
Yes.
Maybe there was some polling, WebEx, I will do the polling. I'm interested to do the polling. I have to play around with this. But I see some people do like instead of asking question, they type the question and WebEx people can answer to that. Anyway. If I do this annotation. Can I write here? No, it's frozen. Anyway, yeah. I will try those things during this term probably. So just talking about intermolecular forces. We have two different types of bonding that we have seen before. One is called covalent bonding, another is ionic bonding. So this intermolecular force does not fall under those two. This is the force, bonding means force, the force that connects the atom to form a molecule. Like, for example, I have to use the board. I'm sorry, you guys cannot see. Like if I write sodium chloride. So sodium chloride is ionic bonding, right? Sodium is a metal, chlorine is a non-metal. So this line does not apply. This is a plus sign, this is a minus sign. Sodium has plus sign, chlorine has minus sign. So that means they are attached by the electrostatic force of attraction, which is called ionic bonding. One is positive, another is negative. So they are connected like a very strong positive negative attraction. So this is called intramolecular bonding because it is connecting two atoms forming one unit. Now intermolecular force is not that. Intermolecular force is when you are bringing the molecules together, how they are sticking together. That force is called intermolecular force. Inter, remember inter means in between. So if I have NaCl and I have another NaCl, how they are connected. That force is called intermolecular force. Okay, so you see the difference? So same way, if I write a covalent molecule, for example, HCl. So covalent molecules, they have a bond in between. You know that valence electrons are shared. So this bond is intramolecular bond. Intra means in between atoms. That's a very strong bond. This covalent bond is very strong. But if I bring another HCl close to the first HCl, then what kind of attraction force will be working? That force is called intermolecular. Make sense? So this is the difference between intermolecular and intramolecular. Intramolecular means it is within the atoms, within the unit, between the atoms in a molecule. And intermolecular force means when you bring a bunch of molecules together, how they stick with each other, how they stick together. That is called intermolecular force. Okay. So there are three types, or basically four types, mostly four types, but we basically discuss three types here. Three types of intermolecular forces that we discuss. So what is the first one? The first one is, you should see here, these are some examples like how the intermolecular forces work between atoms or molecules. So you see three types of IMFs: dispersion force, dipole-dipole, and hydrogen bonding. So dispersion means when you have a non-polar molecule. So in CHEM1, again, I'll go back to CHEM1 sometimes because you guys know the Vespa theory, you know the shapes of the molecules, you know the polarity of the molecule. So those things will be coming again here. So the dispersion force means when you bring two non-polar molecules together, how they feel attraction with each other. That kind of force is called dispersion force. This is an intermolecular force, remember. So non-polar molecule means what? Non-polar, if you give one example of non-polar, we have hydrogen, we have fluorine, any diatomic molecule, non-polar, like HH. Okay, that is non-polar because there is no difference in electronegativity. Now, if you have taken the CHEM one long before, then you may have to look back again. Okay, like what I'm talking about, the electronegativity difference or the polarity of the molecules, those things. So H2 is a non-polar molecule, and we have to find out what kind of intermolecular force exists when you have two H2 molecules. Okay? So let me draw this. So this is one H2 molecule. This is electron cloud. You know that valence electrons are shared. And this is another H. So what kind of intermolecular force you expect? You expect that this hydrogen atom, they have some electrons and protons in the nucleus. And your right-hand side hydrogen molecule, they have also protons and electrons in the nucleus, right? So at some point, if electrons are on one side and protons are on the other side, this hydrogen becomes slightly negative. Delta negative, we say, that electrons are accumulated at one point. And the other side is slightly positive. Okay, so this is called momentary displacement of electrons. The electrons and protons are all in the nucleus. You guys know that in an atom. So sometimes the electrons are just there, you know, they are orbiting surrounding the nucleus. Sometimes they are on one side and protons are on the other side. It can happen. And then you see a very weak distribution between the positive charge and negative charge. Everybody knows electrons are negatively charged and protons are positively charged. So one side becomes slightly negative, other side becomes slightly positive. And similarly, it can happen to the next one. If this side becomes slightly positive and this side becomes slightly negative, then what would happen? You should see some attraction between the negative side and the positive side. And they should attract with each other. So this force is called London dispersion. You see, it is very weak in the sense that we are talking about a microsecond or millisecond probably, where you see that in a neutral, non-polar molecule, electrons are moving on one side and protons are moving on another side, and there is a slight distribution of charges, making the molecule slightly polar. And that when interacts with another molecule, which is also slightly polar, and that type of intermolecular force is called dispersion. So this is very weak, first of all, you need to. And every substance can have it. Every molecule has it. Because everybody can attract other molecules like that this way. Okay? So if the question comes to you like, what are the intermolecular forces present in a molecule? You just close your eyes and first thing you write, London dispersion force. It is named LDF. That is by default present in every substance, every molecule. And sometimes it is also called, these intermolecular forces are called van der Waals forces, all together. Okay? Everybody understands dispersion forces? You guys have question? Like how it is before me, how a nonpolar molecule can have momentary displacement of electrons and how they can be slightly polar and they can attract another molecule with slightly polarity, and that's how they can form very weak intermolecular, which is called dispersion. Question? I'm very sorry, I should show it on the tablet, but hopefully next time it should work because last time it worked. It's just some days. Okay. The next one, it is the dipole-dipole. So what is DDF, dipole-dipole? LDF means London dispersion force, DDF means dipole-dipole. Now this is in case of permanent polar molecules. You see HCl, HCl is a polar molecule because there is a difference in electronegativity. H is positive, chlorine is negative. If you have the periodic table with you, let me open the periodic table. So you see hydrogen on the very left-hand side, chlorine on the very right-hand side. So there is a large difference in electronegativity. So HCl is a polar molecule. Okay? You know that electronegativity increases from left to right. So this molecule is polar, HCl, and hydrogen is the positive side, electropositive side, chlorine being more electronegative. So that's why you see the bigger cloud of electron for chlorine. So that is the negative side. And if you bring this HCl molecule closer to another HCl, where hydrogen is facing the chlorine side of the another molecule, then you have a negative positive attraction because hydrogen is electropositive and chlorine is electronegative. So together they will attract each other. So that kind of intermolecular force is called dipole-dipole because the molecule itself is polar and it is attracting the opposite side of another molecule, which is same. Now my question is, what do you think? Which one is stronger IMF? This dipole-dipole or the London dispersion force that you saw in case of hydrogen molecule? Which one you think is stronger?
The hydrogen?
Hydrogen stronger? This one, this temporary dipole, is this stronger or the HCl stronger? Since HCl is permanently polar, but in case of hydrogen, you are just deforming. You see these temporary dipoles are created because you are trying to you are inducing, right? You are trying to see that at some point, maybe they are deformed. Maybe one side is positive, one side is negative, but actually they are not. So this probability is low, but this probability, HCl probability is very high to attract another HCl with opposite polarity. So your dipole-dipole force is always stronger than London dispersion for any molecule. Okay, any permanently polar molecule will always attract another permanent polar molecule in a much stronger way than you have two non-polar molecules attracting each other. Everybody okay? Okay, so this is about London instantaneous dipole. That's what we are talking about, that momentary displacement. You saw the drawing, okay, like this. So this says the term is instantaneous dipole. So as I said, they are totally non-polar. They don't have any polarity. But due to some momentary displacement of electrons, they create instantaneous polarity. And that is the induced dipole. Dipole means when one side becomes positively charged, another side becomes negative. Then it is called dipole. Okay, and the molecule is polar. And those kind of forces are called dispersion forces. Any question? A question? Okay. So dispersion forces are very closely related to the molar mass. So let's say I take methane. Okay, methane. If you remember, we drew methane in CHEM1. It is a tetrahedral shell. It is a totally symmetrical, and it is a non-polar. So when I say these terms, you have to understand that if we are forgetting those things, we need to bring them back. Okay, we need to learn the Vespa theory once again. We need to look up the book and see which molecules are very common. Those are polar or those are non-polar. Because any non-polar molecules, that's like H2, Cl2, Br2, I2, any non-polar molecule should have the only force that is the London dispersion. Make sense? So nonpolar molecules will have only one type of force, intermolecular force, that is the London dispersion force. Whereas polar molecules will have London dispersion force plus a higher strength, which is dipole-dipole force. Yeah. Now, how the dispersion forces are important, become important in case of higher molar. So let's say I have a protein molecule. You have seen some protein molecule structure like DNA, double helix structure like that. Like they have like 2000 atoms and something like that. Okay. So if you have a molecule that has 2000 atoms, then everybody will be having some electrons and protons, every atom. And those electrons and protons will be momentarily displaced. And they will induce dipole to the other atom. So you see the strength will be very high there. So you can see that at some point it is possible that this weaker dispersion force can be as equal as dipole-dipole force if the molar mass is very high, if the molecule is very heavy, if it has thousands of atoms. Then the strength of the intermolecular force is so high that it becomes equal to the dipole-dipole force. Okay. So dispersion force degree, the strength, the degree of intermolecular force increases with increasing molar mass. The examples of polar and non-polar molecules, very important. I'm going to write here so that knowledge people they can record. Some polar molecule examples. You can take PCl3, you can take HCl, you can take HBr, like that. I'm not writing HF. Why? I will tell you shortly. Okay. And non-polar molecules, any symmetrical you take, H2, Cl2, Br2, I2, okay. Any diatomic molecule, they all have same electronegativity difference. And then we have any other molecule that are non-polar, like BF3, CH4, SiH4, all these symmetrical molecules, carbon tetrachloride, and anything that is not symmetrical is polar, and they will go under polar molecule. So please review VESPER. Know which molecules are commonly polar, which molecules are commonly non-polar. Non-polar molecules means London dispersion force. Polar molecule means dipole-dipole force. Yeah. I hope everybody understands. So here are some, you see, the effect of intermolecular force. Okay, so we understand the force, right? The force that can exist between two molecules, depending on the nature of the molecule, polarity, basically the polarity part that we are talking about. Now, how do you see this effect? The effect you can see by seeing the boiling point or melting point. You see F2, Cl2, Br2, I2, astatine, these are all halogen molecules. And they are getting larger and larger if you go down the group, like I just showed you the periodic table. So F2, Cl2, Br2, I2, AS2, astatine. If you go down the group, you get bigger and bigger molecules. And that means you have higher molar mass. That means you have higher degree of London dispersion force. That means your melting point should increase and boiling point should increase. So the main effect of intermolecular force you see in predicting the substance or boiling point. So you can see the twisted version of the question. Other than asking what is the intermolecular force present, they may ask you which one is higher boiling point. So the substance with stronger intermolecular force should have the higher boiling point. Okay. So for example, next I'm giving you N2 and CO. Now N2 nitrogen gas, is it polar or non-polar? WebEx people, you guys can also answer. N2 non-polar, very good. So what is the intermolecular force present in N2? London dispersion force. Very right. So LDF. And then CO, CO is carbon monoxide. Is it polar or non-polar? Carbon and oxygen, where are they on the periodic table? How do you figure out? Carbon is here, oxygen is here. So there is a difference in their location. So they may have some difference in electronegativity. So the bond between C and O could be polar, right? If CO is polar, then what kind of intermolecular force is present? Dipole-dipole force, right? Now, this is the DDF present. So which one has higher boiling point, CO or N2? Or which one has higher melting point? Definitely dipole-dipole force is stronger than London. So CO should have higher boiling point or melting point compared to N2, right? Everybody okay? So this is how we predict the effect of intermolecular force. Now this slide is all London dispersion force. They are all nonpolar. F2, Cl2, Br2, I2, they are all nonpolar. So that means the only force is London dispersion. So then how do you differentiate if you have only one type of force? Then you go by the molar mass. Higher the molar mass means higher the strength of the London dispersion. And that means it will have higher melting and boiling. See, this is the CH4, SiH4, GH4, SNH4. These are all period 4. I mean group 4 elements with hydride. And since the molar mass is increasing, since you're going to the higher and higher masses, okay, from carbon to silicon to germanium to tin, you are getting the higher melting point or boiling point. Because only force is London dispersion among them. They are all non-polar, they are all symmetrical. So that means you compare between them through the molar mass value. But if you are comparing like one polar, one non-polar, then always the dipole-dipole force is stronger than London dispersion. So this is another slide that shows organic compounds. Now at this point today, I want you, because since you guys are in advanced chemistry course, Chem 2, I want you guys to also get familiar with some organic molecules, carbon family. So you see, this is one, this compound is called neopentane. This is isopentane. Pentane means 5 carbon, and this is normal pentane. So this is a straight chain, 5 carbon. The middle one is one branch. And then the left-hand side, the leftmost one, you see the many branches, right? It is bulkier, like a spherical type. So these are called isomers. They have same number of atoms, okay, these molecules, but they look different. Their connectivities are different, okay? So, and if you look at their boiling points, neopentane has 9.5, isopentane is 27, and normal pentane, N-pentane is 33. So you see that the normal pentane has the highest boiling point, right? So that means intermolecular force is highest here. Higher the boiling point means higher the intermolecular force. So how do you explain? If they all have same number of atoms, how you can explain that a straight chain has higher boiling point rather than a bulky shell? Yes, so see the explanation is given. So since it is a straight chain molecule, so large contact area. The other molecule comes in contact with this molecule, they will have lot of space to connect. So that's why this substance, this rightmost molecule, will have stronger intermolecular force, develop stronger LDF compared to the leftmost one. Because of the bulkier nature, it should have the smaller surface area. And that's why it will coming in contact with less number of molecules, because it is all about intermolecular, how they are sticking together. Okay. So the left-hand side should have the weakest LDF, the right-hand side should have the strongest LDF. See the different variations? It depends on the shape. Before I showed you, it depends on the molar mass. Okay. The shape is not important here because everything is same shape, linear. Now, if you have same number of atoms, but their shapes are different, then you have to see their three-dimensional structure. And that's how the intermolecular force changes, the degree of intermolecular force. Okay. I think we had enough. And the last one, I'm going to talk about the hydrogen bond. Hydrogen bonding is a special case of dipole-dipole force. Special case. Okay, it's a higher level of dipole-dipole force. So what is the specialty about hydrogen bonding? Hydrogen bonding means you have to pick a molecule that has hydrogen. And not only hydrogen, that hydrogen has to be connected to the nitrogen or oxygen or fluorine. Any of these three atoms, any one. So what we are saying that if we have any molecule with hydrogen in it, you take the hydrogen and you connect this to the oxygen. You take the hydrogen, you connect this to the nitrogen. You take the hydrogen, connect this to the fluorine. If this type of bonding present in your molecule, then this is a polar, right? This bond is polar. Hydrogen is highly electropositive and oxygen is highly electronegative. Nitrogen is highly electronegative. And fluorine, you know, it is the most electronegative atom. So this bond is highly polar. This is the negative side, positive side. Negative side, positive side. Fluorine negative, hydrogen positive. So this kind of polarity is much more stronger than other type of polarity. If I write CO polarity, if I write PCl polarity, okay, compared to the other bonds, these bonds are much polar. Okay? So because of this greater degree of polarity, we separate them. We call them, this is hydrogen bonding. Okay? And this is especially important in case of water. You see the unique properties of water. You see ice floating in the water. Why is that? Because liquid water, water is H2O, right? We all know that. Yeah. So we have OH bonds, two OH bonds with the two lone pairs sitting on the oxygen. Again, I'm going back to the Vesper, and you guys may be thinking why she goes back to the Vesper. Because it is all connected. So the Vesper structure of water looks like this. Two OH bonds and two lone pairs from the oxygen. It is belt, polar molecule. Water is a polar molecule. So how come it can have hydrogen bond? If you bring another water molecule close to this, where oxygen is facing the hydrogen, then you have a probability of very strong attraction. Oxygen and the hydrogen of another water molecule. And this DDF, this dipole force is then classified as hydrogen bond. So look, I have two lone pairs on oxygen. So this lone pair can attract, lone pair means negative charge, electron. One lone pair can attract hydrogen from another water molecule. Second lone pair can attract another hydrogen from another water molecule. These two hydrogens from one water molecule can attract another oxygen from another molecule. So per single water molecule, how many hydrogen bonds we have? We are getting total 4 hydrogen bonding. And that's why water is liquid. If you compare other hydrides of group 6, oxygen family, you see how many oxygen with hydrogen, right? If I take sulfur with hydrogen, we get H2S. If we get selenium with hydrogen, we get SiH2. They are all actually gases. Hydrogen sulfide gas, selenium, tellurium, they are all gases. But water, just because it has hydrogen bonding, it becomes liquid because it is so compact due to the 4 hydrogen bonding. The molecules are highly attracted by each other through the hydrogen bonding. So at room temperature, water is liquid. But if you take the solid water, which is ice, the hydrogen bonds are broken because solid water is less dense. Okay, when the water solidifies, it doesn't take this form. It takes the hexagonal form, like this. During the Christmas, you have seen they put the signs of like snowflakes. You have seen mostly like all the festivals and they put this snowflake structure. That is the ice structure actually. That is the solid ice structure they put. So this hexagonal structure is not having those hydrogen bonding. And that's why there's so much empty space in solid water. And that's why the ice is less dense than liquid water. Liquid water is compact with all hydrogen bonding connecting it with each other. But solid ice is hexagonal structure with no hydrogen bonding or very few. And that's why solid ice is less dense. So next picture you are seeing the hydrogen bonding, the 4 hydrogen bonding of water. If I take ethylene glycol, one very common organic compound, can you tell me how many hydrogen bondings are possible? Ethylene glycol is like this. How many hydrogen bonding is possible in CH2OH, CH2O? Ethylene glycol. Okay, now another way I can ask you, do you expect any hydrogen bonding when the hydrogen is connected to carbon? No, because carbon-hydrogen bond is totally non-polar. This part has no ability to attract another one. Only this part will produce hydrogen bond. Okay. So since I have 2 lone pairs on each oxygen, so you are seeing this side 1 molecule, this side 1 molecule, and this hydrogen will be connected to another molecule. So 3 hydrogen bonding possible from one OH group and another 3 hydrogen bonding possible from another OH group. You should have 6 hydrogen bonding. So basically my point is that CH bond is non-polar. So do not write hydrogen bonding when you see hydrogen is connected to carbon. Only when hydrogen is connected to oxygen or nitrogen or F, fluorine, then you should have hydrogen bonding. Okay. So this is not hydrogen bonding. This is not hydrogen bonding. No H bonding. So example that will exhibit hydrogen bonding, that will demonstrate hydrogen bonding is ammonia, NH3, N and H bond, HF, and water. So these 3 molecules in regular everyday life, you will always see them showing hydrogen bond. And in our body, of course, we have all those DNA helix, DNA structure. They have every first oxygen is connected to every 4th one through the hydrogen bond. So we are alive because of the hydrogen bonding. Any question? Anybody has any questions so far? Okay. So see some examples of DNA, RNA structures like this. So your adenine is connected to cytosine via hydrogen bond. Maybe you guys are very advanced. Do you have knowledge in chemistry? I mean biology, so you may have seen this type of structures and hydrogen bonding. Okay, so I will just briefly discuss the properties of liquid. Liquid properties, there are different properties like viscosity, surface tension, and capillary rise. And these are also, these properties depend on the intermolecular forces. So viscosity is the liquid's resistance to flow, right? The more viscous liquid, more it is thicker, you can say. Okay, like honey is very viscous because the atoms are highly connected to the hydrogen bonding. There are a lot of OH bondings. Similarly, surface tension you see here. Okay, the resistance to increase the surface area of the liquid is called surface tension. Water, since it has very strong hydrogen bonding, water should have very high surface tension. And that's why if some insect you see, they can walk on the water surface, but they cannot walk on the petroleum because petroleum is what? Petroleum is non-polar. They have only London dispersion force. So if you just put here some petroleum jelly and you put the insect, same insect, that will not be able to walk. But if you put on water, water has very strong hydrogen bonding. So they are very strongly attracted molecules. So your insect can walk on them. So high surface tension means stronger IMF. And low surface tension means weaker EMF, just like viscosity. Okay. And this is the capillary rise. Capillary rise, as you know, that when the liquid has a tendency to rise against the gravity, and that is called capillary rise. And capillary rise depends, the curvature depends. You see the two different curvatures here. The curvature of the liquid depends on what kind of liquid you are taking. So this is a glass material. The capillary is always a glass. Normally we take the polar glass material. And if you take a polar molecule like water, the right-hand side, the right tube, you see here. So when you see the water is rising against gravity, it always rises along the wall of the capillary. Why? Because the capillary itself is material made of silicon, which is polar, and water is polar. So there's an interaction between the water molecules and the glass material. So water will rise along the wall of the capillary. So your curvature will look like concave, like this, because this interaction will increase along the side of the wall. Good. Whereas if you take mercury, mercury is the left-hand side. Okay, mercury is what? Mercury is non-polar. Okay, it's just atom. If you take mercury in the capillary, mercury has no interaction with the capillary material, glass material, because glass material is polar and mercury is non-polar. So mercury is going to rise along the median of the wall. So when the liquid molecules have interaction with the same type of another liquid or same type of liquid molecules with other liquid one, that is called cohesive force. So in case of mercury, the cohesive force is stronger than the adhesive force. Adhesive means you have two different materials and they are attracting because they both are cool. In case of water, the adhesive force is stronger. That's why it is rising along the wall of the capillary. And in case of mercury, your cohesive force is stronger. The material within the liquid, they are very strong. So they don't need to interact with the capillary material. They can just rise along the median of the capillary. Question? Anybody has any question? So last thing that I would like to stop, I am not going to do the phase transition first. I will do the vapor pressure. So please read this part, like what is vapor pressure, and in next class I will introduce you the Clausius-Clapeyron equation and we will do the phase transition. So what is vapor pressure? I'm just going to tell you today, and then in next class we will see all the properties of it. So after doing intermolecular force, we are trying to see more of the liquid molecules. We just discussed the liquid properties, right? Viscosity, surface tension, and capillary rise based on the intermolecular force. So those are the effects. Okay? Now the last effect you see is the vapor pressure. Vapor pressure means if you take a closed container and in the closed container, you take some liquid. Okay, not open. Okay, the lid should be on. Okay? So if you take a container, closed container with some liquid, what do you expect? The liquid should form a vapor. There is a difference between the term vapor and gas. Gas means you cannot bring it back easily, okay, to the liquid form. But vapor means it is in touch with the liquid. Some liquid molecules on the surface, they have high kinetic energy. They are not pulled back by the liquid, other liquid molecules. You see like that. So they can have very high kinetic energy and they can form this vapor, the dots you are seeing here. So after a point, what will happen? These molecules, these dots, these vapors, they will collide with each other because they are randomly moving, right? Gas particles. So they will collide with each other and they will come back to the liquid phase. So one is evaporation, the liquid is forming vapor, and the other process is condensation. The vapor molecules are going back to the liquid after losing energy by colliding with each other. So when these two opposite processes happen simultaneously, the pressure exerted by these vapor molecules above the liquid at that temperature is called the vapor pressure. So vapor pressure must be associated with liquid. When you keep the liquid in a closed container and you allow to produce some vapor, the vapor molecules, they exert some pressure on the liquid at that temperature. And that pressure is called vapor pressure. So in next class, we are going to talk about how the vapor pressure is connected to the IMF, intermolecular force, how they connect to the temperature, and Clausius-Clapeyron equation, boiling. Read the slides, okay? Boiling, and then this is the Clausius-Clapeyron equation. We have to solve problems. And then, of course, we will do the phase transition. Those two things I will discuss in next class. Heating curve cooling. Any other questions? No? Thank you. And I hope to see you online on Thursday. And start from 101 and let me know if you guys have any question or anything. There should be some questions based on the IMS. Okay. There are many, I think, short questions, not the written problems. Thank you. Thank you for coming and taking my class in this situation. So I'm going to stop the recording now. You guys have any question? The WebEx people?
No, we're good. I mean, I'm good.
Good? Okay. So I hope to see some of you on Thursday or next week. Here.
Okay, thank you.
Thank you. So I'm going to post the recording. It doesn't come within 5-6 hours. Mostly after 12 hours, the recording comes to my WebEx room. And then I'm going to post it.
You know, if they're having lab this week, how they're doing the lab?
Yeah, this week. Oh, you are in my lab also? Okay, great. So this week, everybody is doing like online safety. You have to just watch the video and take the picture. So from next week, we are going to start. So if you are, whatever the group you are, you have to come on those days. Okay? So look at the schedule and please come to the WebEx room. I can discuss more and I can answer all your questions.
When are you doing that?
I mean, now I'm in my office. I can do that. I don't know if there is any class here or that class has moved online. I don't know. So I'm in my office and I can join my office room. If you guys come in, very tough time, very tough time. So you all are in my lab? You are in my lab? Oh, so good. Yeah. So which group? Do you guys know which group?
No.
Based on your last name, what is your last name? Major, right? So you may be in my Group B. I have to check. Okay. And which group you are in? Group A? So that means